Welcome to China Manufacturing Decoded from Sofeast, the podcast where we take you through the major news and topics facing importers and manufacturers in China and Asia today.
Hello, everybody. This is China Manufacturing Decoded again, our weekly podcast, and this is episode 91, I believe. And today we're going to talk about the long-term costs of poor quality and poor reliability of products, right, that are sold in a marketplace. And to talk about this, we have two guests today. This is going to be a great episode. And the two guests have already been on the show. So we have Clive Greenwood and Andrew Amirnovin. And both of them have extensive experience on that topic in various companies that they have worked with or worked for before. So, hey, welcome, guys. Hi, Clive. Hi, Andrew. How are you doing?
Good morning, Andrew. Good morning, Renaud.
Yes, good morning, Clive. And once again, good to be here. Renaud, thank you.
All right, great. So both of you have already been on the show, but maybe some of the listeners are new here. Maybe we can give a short intro. Maybe Andrew, do you want to introduce yourself quickly, and so people have an idea where you come from and what experience you come with?
Absolutely. Well, my name is Andrew Amirnovin. I've been in this reliability and quality business for over 20 years. My background is in electrical engineering, MBA in technology management, and CRE, certified reliability engineer. I worked for companies such as GoPro, LG, AT&T, Nokia, and basically my background is more in quality and reliability engineering in consumer electronics. But I also have some experience in medical products and military type of environments where you actually take into account reliability from a theoretical point of view, from early in development, all the way through the growth period, testing, planning, and shipping it to the customer.
Right, great. Yeah, thanks. And Clive, do you want to do a self-intro?
Yeah, sure. I'm Clive Greenwood. I'm basically a quality consultant working in compliance with medical devices. I've worked for over 27 years now in quality management. I work predominantly with ISO standards and American FDA type standards. My background is in manufacturing quality and quality assurance. I worked with companies such as Nokia, with Sigma Telecom, and with Northrop Grumman. Now, basically, as Renaud says, I tend to be very strong-minded when it comes to quality.
Yes, makes for interesting discussions. Cool. Yeah. So, for the listeners, so Andrew is works with me closely. Actually, he's on the leadership team of our company, Sofeast. Helps our clients build reliability into their products and make sure that it can be tested and confirmed. And Clive is a consultant, and for some very projects that require very deep knowledge of quality and safety standards, especially in medical. Clive is always a good resource for our clients. All right, so let's get into the topic again about the long-term costs of poor quality and poor reliability. First, I thought we would open up with a few examples. What does it mean exactly? What are these guys talking about? So let's take some examples from the recent past that really blew up and have represented humongous costs. So people can actually relate to it and understand, okay, that's what they're talking about. So maybe, at the scale of my company, what would it look like, right? So maybe, Andrew, do you want to start with a couple of examples
Sure.
that we usually give people? Yeah.
Right. I think that everyone has pretty much heard about what happened to the Samsung Note 7 way back in 2016 to 2018. I mean, this is a beautiful phone, and no one ever expected any issues with it. But situation got so bad that these phones were having basically spontaneous explosion of the batteries. And it got to the point that airlines banned the phone from being onboarded, their airlines. I mean, this is a kind of situation where executives who had Note 7, they switched to iPhone or some other phone. The company lost huge amount of customers. The cost of that whole issue was over $5.3 billion. We're talking billions.
That's what the company, that's what the company themselves said, right? More than $5 billion.
That's exactly what they said themselves. You're right. Yeah. It's all documented. But the truth is, exactly. The truth is they probably lost a lot of long-term customers and a lot of other related areas that we'll talk about later. And then, of course, there was this other issue that I think a lot of people heard about it, and it lasted for almost 2 years. And that was the Boeing 737 MAX. These airplanes were just basically dropping from the sky. This happened roughly around 2018, 2019. And there was just a small software glitch, faulty software that caused it. But by the time they figured it out, over 300 people died in these crashes. And it's just uncalled for. All you got to do is make the product better so you can prevent these kind of incidents.
And again, the costs, I don't know if Boeing has put a number on it, I guess so, but it's again in the billions of dollars. And then if you add up also their supply chain, all their subcontractors.
Absolutely. What I heard was that basically some of the costs will be calculated this way. They cut the production by 20%. So imagine so many airplanes that were supposed to be sold, now they won't. And then, of course, lawsuits and a whole bunch of other people had to lay off because there was lack of work. So a lot of, I think that, as you said, it was over several billion.
Yeah, an investigation and yes, much closer monitoring of what they're doing from now on.
Absolutely. People were not getting on these planes for years to come.
Clive, do you have one or two examples to share?
Well, I suppose the biggest one that I worked in over the past 2.5 years was the debacle with the so-called COVID masks. As we know, we've spoke at length, and I've actually wrote 3 white papers on the subject. What we were looking at here is, I spent some time analysing things, and even though I wrote 2 years ago about it, it seemed to be an inconvenient truth for many. That's now resulting in global change in the supply chain. It's now representing significant liabilities, which are during court processes now. The knock-on effect of that was people not understanding what they were buying, and and B, people making things that they didn't have a clue on what they were making, and 3, a complete and absolute failure of quality monitoring systems across the globe. And that's, selling a product which is really a dust mask as a medical product, for me, is totally unacceptable. The other ones that I'm working with are a new one, as we said, which is an electronics failure. And I'm getting to the root cause of this, and this now looks very likely to be a fundamental design flaw, where products are, or components within that product, and Andrew, you better speak more to this, where that they are operating in an environment which are simply not designed for. Right. I'm talking about SMT applications here, where a product's designed to work in a relative humidity average over the past 3 years of 83.7%. And as you know, that's well outside the normal design tolerances for resistors and capacitors, which are placed on boards.
Right.
Again, what we're looking at here is the total effect of this is a company that's actually losing national share of its marketplace. It's already lost at least 3 countries where the product is totally seen as scrap value.
Wow.
This is not good. And, when we talk about, the cost of quality, I mean, I've basically looked at what Deming said, and then looked at what he said and how that's been wrote into national standards or international standards, especially 9001/2015, section 8.3 and 8.5, where design. One of the requirements there is that the design can be manufactured, but what it doesn't say is a design which can be manufactured to a quality level acceptable for its working environment. And I think that is a failure of a quality system to actually understand reality of manufacturing.
That is very true. And that's why people talk a lot about quality and making sure, blah, 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 quality, building quality in the design and so on and so forth. But we are amazed, and Andrew can certainly talk about that, I guess, is how many people develop a new product and think, oh yeah, I want good quality, but they never think about reliability of the product. And yeah, as Clive said, is basically making sure that the product works, in a use case and a use environment that it can keep functioning on. And this is just off people's radar. Is that correct?
Well, if I may jump in there.
Yeah. Absolutely.
The requirement for manufacturing standards and design requirements, okay, let's look at where this starts. I mean, the designers should always be able to provide a detailed DFMEA, because that is where you're going to set the roadmap for quality. We talk about design for quality, but really what we're really meaning here is the design itself should be evaluated with known and unknown conditions, which may or do apply. Now, if you look at section 8.3.5 of ISO 9001, and also section 8 of ISO 16485, and if you want even to go into section 7 of TS 16949, every one of these standards talks about understanding the customer requirement. Now, the customer requirement, and let's be brutally honest about this, the customer requirement is that the product works and is reliable. Yes. Nobody wants to buy a product which doesn't work, and no one certainly doesn't want to buy a product which is unreliable.
Yes, and how long is going to keep working?
Yes,
how
exactly.
They're going to use it, in what environment, and And if some people are in Tucson, Arizona, and some people are in somewhere in Alaska, well, it's got to work for all of them.
Yeah. I mean, so what I've looked at here is COPQ, which is cost of poor quality, and the source of good quality, COGQ, which is the cost of good quality. Now, where I feel that people misunderstand this is they don't realize that the total cost of quality, or basically the accumulated cost of quality, is a mixture of these two things together. So the cost of poor quality plus the cost of good quality to get a total idea of what the cost of quality is. Now, if you are having to build repair facilities outside of your manufacturing environment, that is a cost. If you're having to, in today's world of high shipping costs, if you're having to actually recall products, then this is a pendulum which can swing in any direction, and then it's really outside your control of cost. So you can't build that into any model. So what I'm suggesting is this, that product designers need to be more akin to engineering and the engineering requirements. I mean, would you agree with that, Andrew?
Yeah, I do. Actually, I think that in order to really prevent this cost of quality and be able to have a better, more reliable product, then the first thing you need to do is think about how you can make your product design more reliable, right? And the next thing is how you're going to test for reliability. And of course, manufacturing control for reliability and also manufacturing testing. These are critical, let's say, tasks that needs to take place during the development to ensure quality and reliability. And I think if you bypass or miss any of the key tasks in this process, you're looking for trouble.
Absolutely.
Yeah, I mean, you're familiar with PDCA and the principles rely all around PDCA.
I think so, yeah.
I've actually said that, okay, before that happens, there needs to be an I in there, which is the identification.
Right.
So I identify, plan, do, check, act, and have that as a constant revolving door, yeah?
Exactly.
Now, if you can remember your days back when we used to do the Nokia drop test, remember that?
Absolutely. Nokia invented the drop test.
Yeah. How many times could you actually replicate the same amount of failures? Because it wasn't structured in a way. It was, okay, the phone shall not split apart or the screen shall not break and things like this, yeah? But you could actually pass the test, but when you actually looked and did an X-ray on the boards and things like this, all sorts of problems were found, yeah?
Of course.
This, if you're not familiar with this, Renaud, it was a simple case that if the phone was dropped from an average desk height onto a concrete floor, what would happen? And it shouldn't break or split apart and stuff like that, yeah?
Yeah, well, the covers and everything disintegrate, basically. Battery comes out.
Yeah.
Right.
Yeah, I never forget that because in Nokia, we found that happening a lot. So we decided that we'll just go ahead and consider that as a normal thing. And they actually designed it so that it would disintegrate and not damage the internal. But I wanted to get a little bit more, I don't know, Renaud, if you have a little time, I want to get into how to make a more reliable product so you can actually prevent all those cost of quality.
Yeah,
and,
let's go into
go
this
ahead.
exactly, yeah. And then because the topic is actually what, these costs. So then after that, we'll go into the like typical sources of costs. But since, the discussion is going in the direction of what to do to prevent all these issues, which is the most important, definitely please keep going, yes.
Yeah. I think that to make a reliable product, well, first thing, you must consider the design to be reliable. I mean, to do that, you have to look into use case environment for the product. You really have to understand that. You have to look into how to do design for reliability into that product. And then with reliable components and materials, I mean, that is really, really the key, because a whole product consists of, several hundred, sometimes components. And all you need is one and not to be reliable, and you're looking for trouble. And of course, looking into DFX process, design for excellence, like design for assembly, design for manufacturing, design for reliability, design for quality, and
design for testing.
Exactly, design for testing, and you can't do without design FMEA for basically risk analysis, risk assessment, and then in mechanical engineering, you should do FEA, finite element analysis, and look into components and suppliers that have reliability and quality systems. And then, of course, analyze and keep track of the history of the field failures. This is like the first basic right at the beginning of the design. Now, once you go through that, like you said, Clive, then you've got to test it, right? If you don't have some kind of a really good reliability testing methodology or process or plan, how are you going to determine if your product is valid in terms of reliability. Is it passing or not passing? You would never know. So it's very critical that you understand how the customers will use this product so you can test it, right? And plan for that testing and consider product storage requirements. Be mindful of how the product's going to be shipped. Is it going to be by boat, by airplane, by truck? Imagine, it's going through rough roads on truck. I mean, the vibration alone could damage the product. Creation of appropriate reliability test plan is really the key and critical. There is this new process that came about with, I think Dr. Hubbs was the inventor of it. It was called HALT and HAS. And that's a great, in my opinion, that's one of the latest reliability techniques that really works in terms of accelerated life testing for certain products that, certain size and weight. And I really think that it does help accelerate finding the issues early in the development so that you don't have to deal with it coming from the field. So I don't know, Renaud, you want me to talk about the manufacturing control for reliability and testing?
Well, I mean, everything you said is spot on. There's also the selection of the suppliers.
Yes.
Maybe Clive, do you want to talk about that?
Well,
because
I just follow on with what Andrew's saying. We must accept, that any product, no matter what that product is only as good as its weakest link.
Exactly.
And if that weakest link has been chosen because of price over quality, then you have a product which is wishing itself to fail.
Yeah.
So first and foremost, we must make, or I try to explain to clients that not only are you looking at the cost of quality as in failures, which is quantifiable, you're also looking at cost of failure as regards the company's reputation, as we say with Samsung, something that it will probably take years to recover.
Exactly.
Boeing's embarrassment is a classic case, okay? But there are so many more. Now, if you are choosing a supplier that doesn't have what we would call a recognized quality system in place, one which you can audit and verify, then you might as well basically just throw away all claims of quality of a product, in my view.
Right.
And, because it simply is you cannot substantiate it.
And it's not just about the quality system, right? There's also, they might also have their own test results and specifications and so on. Ideally,
if you don't have a quality system, you cannot verify it. Mm-hmm. Your quality system is used there to verify of what you do. If you look at, let's say, the easiest standard that we know of to get is ISO 9001:2015. Mm-hmm. Providing you say what you do and you do what you say, you can actually get that certification. And for me, this is a baseline entry. It's not something which is a gold standard by any stretch of the imagination whatsoever.
That's for sure.
Okay. Yeah. Now, the implementation of your production quality, your design quality, as a proven, verifiable, and validated system is the starting point where you can at least trust a percentage of what the supplier is saying. Not everything, but a percentage of it. Mm-hmm. Now, let's assume, and we come across this, as you well know, in Asia, that component buyers buy the cheapest thing that they can, and quality is very rarely brought into it, or at least, or probably as a last-minute thought. Mm-hmm. Whereas what we are saying is that quality should be the first thought, not the last thought. When people are designing products, they must think about the manufacturability and the components and where these components are going to come from, how they are going to control the qualities. We all say,
Yep.
okay, you give us an acceptable quality limit. Okay, well, as Denning said, if you cannot describe what you're doing, then you don't know what you're doing. Now, let's look at this in a realistic and holistic point of view. The designers design to a customer requirement. So do we understand what the customer requires? That's exactly what Andrew said. You've got to know, this is why we have in the medical device industries, you have a pre-market survey and a post-market survey. Your post-market survey tells you how you're doing. Doesn't actually stop you from doing it in the first place, but it does on a future model, shall we say.
Yeah, it's a bit too late, right? Yes.
Yeah, it's a bit too late. Yeah, the horse is well out of the stable and halfway to the next town before you find out that you've done something wrong.
Yes.
Okay. The aspect of what I'm saying is that the total cost of quality, in its combination of both the cost of good quality and the cost of poor quality together, and the cost of rectifications, must be thought of at the design stage.
Yes. Oh, yeah.
Because without that, you cannot build a real design evaluation. You certainly cannot do a risk analysis, because your risk analysis would say,
correct,
item 1, line 1, I don't know what I'm doing.
Correct. Yeah, and it comes back to what Andrew was describing. It's really
exactly
same ideas. Yes. You analyze, you think of the risks, you try to take it into account as you design the product, and you also try to specify certain things about the components themselves at that stage, so that a procurement agent cannot just run off and pick the cheapest one or the easiest one to buy or whatever. The one that would send a few parts just for prototypes, the fastest without charging or something like that. No, that's not.
Yeah,
that's not.
And if you're going from that point of view, and I think Andrew, you back me up on this, there is no way in a million years can you make any assumption about reliability from that point forward.
Yeah, absolutely. I think honestly, to your point, a lot of times what happens in development is that all these engineers, and I mean all of them are good engineers with good intentions, but unfortunately they become tunnel vision. Here's my project. I've been told to design this and I'm just going to do that. They forget the fact that you have to look into the big picture of how this product is going to be used in the field by the end user, by the customer, and what kind of environments could be impacting it. Are they going to use it in Alaska? Are they going to use it in Hawaii? Each one of these environments is going to have very interesting impact on the reliability and quality of the product. The other thing that you brought it up to your point, Clive, is that many engineering levels, they don't really understand quality and reliability. And, and I don't think, it's really their job. That's fine. But many higher level quality and reliability teams need to educate the development team on very simple questions. What are you designing? Do you know your customer requirements? Mm-hmm. How are you going to manufacture? Do you know how to test it? How are you going to evaluate the design reliability, design quality? And if they don't ask these simple questions from those team members, I think you're looking for trouble.
I think so, exactly. Okay. I would say, I do actually run training courses, as Renaud knows, for people to try to get them to understand that, if you put an engineer in a room with some quality guys, he's going to feel very uncomfortable. And that's probably the wrong way of looking at it. But if you actually, my train of thought is taking me to a basic fundamental aspect when it comes to manufacturing. That is that the design manufacturing, or the design to manufacture, should I say, has to have the design to manufacture at a quality limit. Now, let's assume that your quality levels will always relate to the product price. No matter which way you look at this, it's always the same. If you are making a low-cost product, do you sort of fudge the issues when it comes to quality and reliability? And the answer to that was, if you have a short-term business plan, maybe. But if you're wanting to build a business as a long-term view, in this I mean 5, 10 years, 15 years, then the concept of cheap product must be equated to throwaway product.
Okay? Exactly. Yeah.
Okay. This, when it comes to mind, is the current trends of mobile phones. Your mobile phone is probably only good for 12 to 18 months, and then you might as well throw it away. Yeah.
Right.
Because if you look at the recharge rates of lithium-ion batteries and lithium cobalt batteries, you're only looking at maybe 3,000 cycles, and then the battery itself is gone.
300, you mean?
Right.
Well, yeah.
Right.
But yeah, I mean, you could say the same with electric cars. Okay.
Yeah. Eventually.
You've only got so many recharge cycles before you have to throw away the engine. That probably is not very good.
Well, okay. Plus in the latest Tesla, it's what they call structural batteries. So you have to throw away the entire car. You can't really take the batteries out.
Yeah, you throw away the car. It's throw away technology. Mm-hmm. But okay, so the question would be, can you have reliability at a lower cost? And I don't know of anybody that's actually managed to crack that one yet. There is always an offset, yeah?
Yeah, so that's a very, very good topic of discussion. I don't know if we can actually cover that. But I'll tell you, I totally agree with you. I bought some Christmas lights, right? And very cheap, very cheap. How cheap? I'll tell you how cheap. The plug that you plug into the wall has wires coming out of it so thin. And we're talking, city power, right? 120 volts is coming out of these two thin wires. And I accidentally knocked this little box that has the buttons, to turn the switch on so that the lights flicker different, rates. Well, the box opened up, and I was imagining some kid not knowing what that is, and then just putting his hands right on top of the box, which is totally open, and electrocuting himself. And it's just a $5 lighting. So that is, I consider that irresponsible product development, where you don't even have the basic safety for covered in terms of being electrocuted, right? So I think, honestly, I personally would stay away from what I call really, truly cheap product, because yes, you're right. In those kind of situations, in those kind of products, quality and reliability was not even a factor. They didn't even consider it. But if we're talking about standard products for day-to-day use and so forth, I would assume, I don't know if you agree with Clive, but Renaud, I would say that you definitely want to at the least cover the warranty period, not only to cover your losses, but also that should be a standard minimum reliability testing so that it at least lasts for a year. And then sometimes companies get lucky. If it lasts for a year, maybe it'll last for 5 years, right? And maybe if it lasts for a year, maybe it'll last for 10 years. You don't know, because there's that statistical probability thing that is work. Because if they did the test and they caught the main issue and fixed it, most likely it'd be a good product.
Yeah, I mean, that's where national standards comes in, and compliance to these national standards, which is obviously, as Renaud will tell you, I'm very black and white when it comes to that. It either meets the standard or it doesn't meet the standard, and there is no in between. Products which are supposed to be sold in a particular jurisdictional location or geographic location must meet that international or that national standard. That is simple, plain, and unrefutable. The problem is how many, shall we say, men in the street can walk up and say, right, that product should meet ICEE standard number so-and-so or so-and-so. People are really just not educated in a way when it comes to product safeties and product reliabilities, because they're only interested, and let's be truthful, they're interested in how it affects their pay packet. The whole concept of safety reliability is often trumped by it's cheap.
Right.
Oh, yeah.
And
it's not a level playing field.
Yeah, it's not the same. I mean, I can remember when I rebuilt a BMW 250, if you remember those, which was a straight six. Yeah, I rebuilt it. I bought it from a scrapyard and totally rebuilt it. And when I was rebuilding the engine, I saw that the crankshaft was a little bit tired. Yeah, so I wrote to BMW, "Can I get a new crankshaft?" Absolutely. So anyway, I said, "How much?" And I got the message back: BMW crankshafts don't wear out. And I got one back in the post.
Oh, wow.
Okay. Free of charge. Yeah. Now, that to me is like, well, I wasn't asking for a freebie. It was a simple case, I was asking a question, where can I buy a new one from? The guy says they don't wear out. And I got a nice new shiny one. And that to me has always stuck with me as being, this is what it means by investing in your product.
Yeah, because they basically they got the bad one from you because they're going to learn so much from it.
Yeah, exactly.
And that's why they give a brand new one. Yeah, I've seen that a lot. So Renaud, you want to basically guide us through which topic we should be talking about?
Yeah, right. Yeah, because the topic is about the costs themselves, and really, we touched on it quite a bit here and there. But if we try to make a list of these typical costs, once let's say bad products reach the marketplace, what are they, right? Because it's actually not a short list.
Well, right. No, it's not. It's rather a long list.
Right. What comes to your mind?
Now, shipping. I could put it down to shipping costs of recovery. I can put it back to rework or re-engineering. Then a total recall of product, which now you're coming into irreparable damage to reputation.
Yeah. I could add to that a couple of more. I think that
go on.
As you mentioned in manufacturing, you probably have to have, because you didn't have proper quality and reliability testing, and you're catching all kinds of issues. Now you're thinking that I need probably new inspection points, right? To be able to catch these issues before they go out. Then you have increased rework and repairs happening, massive returns and product recalls. You're allocated different kind of rooms. Where are we going to store these so that we can have time to rework these? A lot of people, manpower being allocated to these returns, loss of sales and revenues, this customer dissatisfaction, tarnished brand image is the biggest one that happened to Samsung at that time. That was worth billions. Customer complaints and investigations, of course, high warranty costs. This is the big one. You never really want to pay warranty. And whenever you have that is a sign of a poor quality. Need for excess inventory. Like I said, find the space to store. And then finally, we talked about it, legal fees and fines because of issues happened, people died, or, financial damages.
Right. And let's take a simple example, because people sometimes don't really realize that, because all of this sounds a bit abstract. But let's say you sell a product, let's say in the US, and you have and you say, okay, let's budget for a 5% return, which in some product categories is not crazy, especially, if you sell on Amazon and people can just send you back anything for any reason, and you can't really fight back. But there are some other channels like that. 5%, what exactly does it mean? I remember there's a few examples from past clients that really stuck with me. I remember an example of a company that sells like train sets and things like that. These complex toys with a lot of accessories. Okay, and in many cases there was a problem of like one screw missing. So people, especially the manufacturer in China, did not understand what's the problem. Yeah, from time to time we're missing one screw. Yeah, sorry about that. Sometimes there's 2 screws extra, whatever. But for the brand that was selling that, that means, number one, a very upset customer. You ruined my Christmas. We could not make it work.
Right.
It was a Christmas for the kids, and it was a centerpiece of the evening, and it didn't work. Second, they had to FedEx one screw in a hurry. That was, with the labor together, it was more than $50 every time, just for one screw, right?
Right.
And then, of course, bad reviews in social media and on Amazon pages.
Yeah,
and everything.
there is this one that we haven't touched at, which is the double-edged sword of social media when it comes to quality. The reaction is probably now. Well, it definitely is more instantaneous because of social media, and thus the veracity which it can come back at you is much more than what it was before. I mean, before social media, basically, you could get away with 100 returns or 200 returns, and it didn't really make much difference. But nowadays, those same number of returns has a knock-on effect which can quantify by a factor of 3,000%, whatever, simply because of social media's effect that there is on product branding now.
Oh, yes.
So, I mean, I want to get back to this idea of why is this going on, and I've got one big note that I wrote on my piece of paper here.
Go ahead.
And something which I push whenever time I do a talk or a speech or a lesson, okay. Which is that product quality and reliability failure is a failure of leadership. And this is what we need to get over to people, that it is, in fact, the vision and the leadership and the investment, which is now, shall we say, led by accountants and not by quality people. This is what is a crux, I believe, with many of these failures. Would you agree, Andrew?
Yeah, I totally agree. I think that way back, a good example would be like this. Way back when I was a young engineer, I had a cold call from a company that they had a very, very low throughput in manufacturing. And I recall going for an interview, and I said, let me take a kind of tour of the manufacturing and development team areas. And I found out that they had no kind of quality and reliability, process or procedure, not in the development with the design and the engineering teams, and not in manufacturing. So, yeah, of course, I told them right away that if I had to do and put together a process, I had to have management support. Why? Because to your point, Clive, every time quality and reliability professionals always have to be in battle with the design team. There's always this point of contention. I really need to test for this. And the designers come back and say, no, you tested it too hard and you broke it. And the fact is, there's a really a fine point how you develop your test plan so that it doesn't go test a failure where design engineer would be right, and or it doesn't pass automatically where the reliability engineer wouldn't be doing his job. The idea is, how do you find that perfect test plan where it catches the issues, but it doesn't necessarily do a false failure? This is the art of a reliability engineer. And this is where the only way you're going to pass the point of contention with the design team is to prove it from one build to the next, that here it is, we found these issues in reliability testing, and the design team says, show me, and you show them, and they go and test it, and they say, oh, by golly, you were right.
Yeah. So
and
repeatability of tests.
Once you've done that right, then you got the design team on your side, because now they're looking at you as a support, as someone who's going to help them not be embarrassed at the end of the day.
That's communication, though.
Exactly.
I mean, that's why I always tell people to build an obeyer room. Okay, build an obeyer room, and do not silonize the design team, the manufacturing team, the testing team.
Exactly.
These need to be a team of one. And I found that the best way is to have an obeyer system, which allows people to easily visualize what you're saying, because we in quality, we can be very conceptualized. We look at what ifs, whereas designer, well, this is what I need to do and things like this. So I believe that communication is a key factor in getting to what you're talking about there, Andrew. Yeah.
Yeah, absolutely.
Just to make sure people understand, the obeyer system with the obeyer room and so on, doesn't have to be really in a room. I mean, that's often done, and that's very good. But I think the key idea that you mean, Clive, is that make the facts, speak to people, make them visible to everybody. Make it very clear where there are issues, make it very clear where improvement is needed, make it very clear who has to do what, and bring people together around these to visualize it, go over it, and sort of agree and commit to working together to fix these, the data and the trends and so on for the improvement of the whole company.
Right.
Yeah, good.
Yeah.
This and that's management. It goes back.
Leadership. Yeah.
Yes.
I mean, this is where I said IPCDA, because if you follow that principle,
yes,
you are identifying issues.
Oh yeah.
Identify the issue, and plan a way to actually test that issue.
Oh yeah. Oh, it shows you where you need to work on and so on. Absolutely. And I think, Deming was saying that something like 85% of the issues actually can only be fixed by management, because you need to put the system in place, and that's what will create the issues or prevent the issues, and that's what would really determine the whole company performance, right?
Right.
I think it was 85%.
I think in reliability engineering we use another tool called Pareto analysis, where it kind of uses the same methodology as Deming said on that 85. So a lot of times what you see is that maybe one or two critical failures are causing 80% of the problem. But as a good reliability engineer, you really need to identify that to the design team. They don't know. They don't know what it is that you want them to fix. And once you identify that one critical component, they will love it, because once that you fix that, you don't see that again in the next build, then you know you've done a good job.
Right. You help them put the finger on what needs to be improved.
Exactly. Yes, it's totally right. Totally right.
Yeah.
You've got to look at what I'm doing at the moment, which is root cause analysis, is everything that I've seen so far, always, when you drill down into it, it always comes down to, have we analyzed what this is going to do? Yes. Have we? Right. Okay. So I ask a couple of questions when I go to companies. If it's in the manufacturing, I ask them what their CPCPKs are. Now, if they can't tell you, that is a worrying sign, okay? Straight away, that's a red flag.
Do you mean if they're tracking it?
Yes. Yeah. If they're tracking it, yeah. Right. And if the answer is no, well, okay, let's talk about your certification and your accreditation, because obviously, are you given the resources? And if you look at what it says in section 2 of ISO 9001, okay, when it comes down to leadership and management shall provide the necessary resources too. Yeah? Yeah. So, yeah. No, we don't have any budget for quality. Okay, there's your second red flag. And to me, I'm at the point of walking out from that supplier, basically.
Right.
Yeah.
One thing that maybe Clive, you can talk about one area that I really like in quality, and that is 8D, corrective action process. I think that is really a critical process for root cause analysis, isn't it?
Yes, I would suggest that if you're looking at the customer corrective action requirements, you must be looking at what point did the need for corrective action start. Now, obviously, when you're looking at customer complaints, you have to assume, and here's where it comes in, you assume that the customer has used the product within its design limitations, correct?
Right.
Unfortunately, you cannot prove that.
Yeah. Yeah,
okay?
but the part that
in automotive you can, because now the car records everything the driver has been doing since it left its last service. Yeah.
Right.
With other products, that's not so easy.
But Clive, the part of the 8D that I really like is the fact that you find some field issues on a current product, then most often what happens is that the engineer responsible for finding those issues from the field, he fails to report it to the design team that are working on the new product. So I have seen over and over, because new products are based on old products, right? So they take the old product and they change form factors, put a brand new chip that is high speed, for example, high frequency. And then now nobody knew that there was this field issue. Nobody told me, and I didn't redesign it. And I just shipped this brand new product with the same issue that has been happening with the old product. This happens so many times. And so lessons learned.
Communication.
Right.
That is why I suggest to companies that your Obeya system is a way to ensure that you've got free flowing communication between departments. It's very rare, and I agree with you, it's very rare that a customer complaint or a corrective action ever comes up to the design team. And that is where, if you looked at common failures across platforms or common failures across products, often happens. And you're right, it is because known problems or known issues haven't made its way up the design chain.
Right.
That is failure of communication.
Yeah, logging the issues, and this is really
it's not just about logging it.
Yes,
to be honest with you, Renaud,
of course.
It's about how that communication goes back up the chain within the company.
Feedback loop, absolutely.
The feedback
and with the
loop.
suppliers. Yes.
Yeah.
Oh, no, absolutely.
So this is often a break, and Andrew's correct in what he's saying. That the issue of how field failures, or in fact failures online or failures during test, don't make its way back up to the designers. Now that is a failure of your QMS.
Yes,
definitely. Yeah.
So. And if you're not tracking this, and you're not even tracking the communication, and you're not measuring the communication, then you're not getting the vital information to the people at the design end, because simply they haven't been told that something will fail. They are not manufacturing engineers. They're not reliability engineers. They're designers.
Right.
And they cannot be expected to keep their finger on the pulse of what's happening within their product when it's out in the marketplace. It's not their remit.
Absolutely.
Right.
And
Okay.
I think as it's time to wrap up, I think we can all agree as a conclusion, that management has to set the right system, has to set, as you say, the right feedback loops, has to make the right facts, visible and make them available to the right people, so that the designers can actually work well with the reliability people, with the quality people, with the procurement people who will know what to do, what not to do, and that is critical. And without that foundation, a company cannot be expected to develop and put on the market good products. Is that a good way of putting it?
Well, I was going to say, to your point, just kind of to summarize for our listeners. So I think that you have to look at it this way. If you're looking at it from high level, for the design and development point of view, you must have a way of identifying your issues before it goes to manufacturing. You must be able to validate the product and verify if there are any issues before you go to high volume manufacturing. Once you go to manufacturing, you have to also find an inspection point, like to Clive's point, and you need to do some pilot runs on materials and components. You have to have a process for incoming quality control, FAI, in-process quality control, or outgoing quality control. You have to have ORT, ongoing reliability testing. You have to have all of these processes in place to find the issues before it goes out the door.
Yeah, I mean, I would add to Andrew's point there. What is the point of building a prototype? It's to find out where it fails.
Yes, exactly.
Yeah.
One of the key objectives of prototypes. Absolutely.
Yeah.
Absolutely.
It's not to find out how it works or if it works. It's to find out why it fails.
Yes. All right. Yeah, thanks. So it's time to wrap up to make sure the episode doesn't last 2 hours. Thanks so much. I think that was a great discussion. Thanks a lot, Clive. Thanks a lot, Andrew.
You're welcome. Nice to
pleasure.
meet you, Andrew.
Yes, same here. Thank you.
Yes, and I'm sure we'll see you. We'll hear from you again in future podcasts, maybe probably on related topics. Thanks for the listeners. I'm sure this was quite an enlightening and interesting discussion, and you will hear from us next week as usual. All right, so speak to you next week.
Thanks again for listening to this podcast, brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.